Sharad right here. Sharad Sharma, he is working with Broadcom, and he is an alumni. So he was studying electronics engineering right here in Cochin University, just like you guys. And he's one of the few people who's still in the same field. So yes, that's true. So what he's going to talk about is how you should stick on to this field and not go to IT just because there are more IT companies coming, but why you should stick on to electronics and what are the job prospects right out there. So Sharad, over to you, and thank you for doing this.
Okay, no problem, Maya. Thanks a lot for inviting me for this.
Sure.
So hi guys, as Maya told that this talk would be basically about semiconductor industry as a whole. What are the trends, the outlooks? And mainly, most importantly, it will be for you guys to see what lies ahead for you in terms of job prospects, in terms of your future learnings, and in terms of what you can do to be industry ready. Because as I was talking to Maya, there is a certain gap that is there between. Sorry, there's some echo somewhere.
Sorry.
Yeah. So yeah, that's basically the talk that we'll have. The agenda for the talk would be a little bit about me. I'll keep it very brief because there's not much to talk about there. We'll talk about where the industry is today, where it is heading, what are the trends for the future. So from your point of view, what are the things that you'll be working on once you are graduating, other than what we are working on today, because it's a constantly churning industry. Things keep changing day by day. So what are the trends that the industry leaders are seeing and where the investments are happening? Finally, it will be what you as a student can do today to be ready for that change that will happen. And the Q&As, you can ask the questions in between also, that's not a problem. And I'll try my level best to answer them today. If not, then I'll probably try to find out the answers and get back to you if there are some things that I cannot answer at this point of time. Okay. So to start with, about me, as Maya told, I'm a Cusat pass out from ECE. I passed out in 2001 and I joined the industry immediately after that. So it's been 18 plus years now. At present, I'm working as a senior manager in Broadcom. So a small question to you guys. How many of you know Broadcom as a company? Anyone can answer it if they have any idea about Broadcom. Okay. So Broadcom is a company which claims that 99.99% of all the data that you use passes through at least one Broadcom chip. So that's how big Broadcom is. Mainly if you're using an iPhone or any Android phone for that matter. 99% of the Wi-Fi chips that will be there would be from Broadcom. Qualcomm has the Snapdragon, we have the Wi-Fi's and the Bluetooths. So prior to this, I worked in Qualcomm, TI, Freescale, Wipro. Basically, a multitude of companies and multitude of segments that are there in different streams that semiconductor industry gives to us. Okay, so the main topic as to where is the industry today and where it will be heading. So I'm not sure if you guys know, but semiconductor industry is a pretty cyclical industry.
Sorry to interrupt, Sharad. Actually, we can't really see your presentation. It's just stuck at the first semiconductor trends and outlooks.
Oh, okay. Let me just try to do that again then.
Sure, thank you.
Is it visible now?
Yes, it is. Yes, it is. Thank you.
Oh, great. Yeah, so as I was saying, the industry is a pretty cyclical industry in its nature. So it has its share of uphills and downhills. It declined quite a lot in 2019, but it is growing at a rapid pace since the lockdown, ironically. One of the main reasons is all the companies are buying, keeping in demand whatever is the increased demand that has come from people working from home. So broadband chips have increased, the industrial chips have increased, your data center requirements have increased exponentially since the lockdown. So the industry is again seeing an uptrend. And it is cyclic in that nature that because any change in the technology that happens requires a lot of investments from all the OEMs, all the switch makers, Facebooks, Amazons, everyone. So they tend to make the investments once in every couple of years, not every year. So they'll make big investments now, they'll shut down for some time, no more investments, and then later on they would again make big investments. So that's why we say it's a cyclical industry in that sense. So because of the lockdowns, we see a lot of growth happening in servers and memories. And Moore's law, I'm sure almost every one of you know that, and that still holds good. We are moving from 7 to 5 to 3 nanometers now, and it will continue to evolve as we go forward. So yeah, that's where we are as an industry today. Where we are heading, at present, the growth will at least continue for the next 2-3 years. Every big semiconductor manufacturer is already booked for the next 3 years at least, with orders, actual orders from the OEMs for their chipsets. There's a trend happening of big fish eating the small fish. So all the big semiconductor companies are acquiring their competitors or something, some new company which is doing something which is a new breakthrough that is happening. So we have NXP acquiring Qualcomm acquiring Nuvia. NVIDIA is in the process of acquiring ARM, which is kind of the heartbeat of the semiconductor industry. And what we are seeing is every big semiconductor player has its own niche market. So for example, Qualcomm is completely focused towards cellular. TI is completely for TI. When I say TI, it is Texas Instruments. So that is completely focused towards analog. NXP and Broadcom are towards networking and server domains. So yes, so everyone has its own niche market, and they're trying to keep finding ways into poach into other guys' stuff, and that's how the whole game is played. The R&D spending from every company is going up and up as we move forward, and that's basically to try to get into new avenues and for innovations. Okay, so we talked about the nodes. So this is the trend that we have seen from start in 1987 to what we had in 2019. We have moved to 2021, which is 3 nanometers now. So you can see there is a constant downward trend towards the node. Yes, it is becoming a little harder as the years pass by because of the subatomic physics that comes into play. But innovations are happening here as well, and we continue to cram more and more transistors into the same die size, and that helps us building more and more complex circuits, more and more functionalities into the same die size, same chip size, which you would be using probably 3 years back. And that helps us in building new functionalities and new applications for the users, the end users, you and me to use. Okay. Moore's law, as I said, is still holding good. We started with in 1970 with say 1,000 transistors on a die, and it has moved up to, I'm not even sure what the number looks like, 50 billion or 50 million as it stands today in 2020. So these are the chips. So as the nodes decrease, the number of transistors on the die increase, and with the number of transistors, the circuit complexity increases. So yes, there is a lot of things that are happening in the industry. Any questions so far? Okay. So yeah, so the technology trends. I guess all of you read newspapers, so you would be reading a lot about 5G and IoT and AI. So from that point of view, we would say that 5G is the absolute golden egg or the golden goose for the industry. The reason we say that is because 5G would mean that there is nearly an exponential growth in the market in terms of the data usage that we are using so far from 2016 to today. It's been a 7x increase in the mobile data usage per user across the world. 5G is an evolution that happens over LTE, and that started as something that was started as a consortium of few semiconductor companies in 2012. And the aim was to give a magnitude of 10x over 4G in every parameter, whether it is speed, whether it is latency, whether it is security. The target was to give a 10x improvement over every parameter that an end user can think of. As we stand today, it's pretty much a standard right now. The deployments have started across the world. Even in India, I guess Reliance announced something day before yesterday for the same. Only problem today with 5G is that the cost of deployment is high, which is understandable because it's a new technology. But it's a market of scale. So once you scale up, the cost would come down. But from a technology point of view, it's absolutely the future. You cannot stop it, and this will lead into a lot more innovations in the coming days. Now, when we say the 10 parameters that we talked about, so this is what is a basic comparison of 5G to 4G. So the light green ones are the ones that are there for 4G. So if you see, max speed for 4G is mentioned as 1 Mbps, 1 Gbps. And the max speed for 5G would be 20 Gbps on your mobile phone. From the user data point of view, 10 Mbps is what you'll get as in 4G right now as an average speed. It will increase up to 100 Mbps as an average speed even in the most congested of clusters that are there. Network efficiency would be 100x improved, so you will have a lot more devices in the same cell than what you have today without seeing any degradation in terms of speed. The area capacity would increase in terms of the same antenna would be covering a much bigger area and the cell size would also increase as compared to what we have today. So as you can see, so 5G is giving us an improvement through and through in terms of spectrum all across the user experience. Now, what will that help us in? That will open up a lot of use case scenarios where the industry is looking in right now. I guess most of you have Netflix and Prime Video accesses today. What you'll see with 5G is you can see 3D videos over the internet directly from there on. You can play video games or your Xbox consoles directly without even needing a console. So there'll be a cloud in which the game is running, like Google Stadia, for example, and you can play it, stop it anywhere, and pick it up anytime where you left off at some other place. You will have a lot of improvements happening in the medical science industry. Because of this increased bandwidth, there'll be things like remote controlling of robots for doing operations and all. You'll have enhanced security with a lot more data coming in. So facial recognition and all those kind of features would improve a lot. Connected car features would be there. So auto driving, which is in its infancy right now with Teslas and other companies coming in, would be improved over a margin of at least 100x over the next couple of years, because a lot of the data that is coming in can be sent to the data centers for processing at a much higher speed. So so that's what 5G is kind of giving us as a scenario for us to work on in the future. Okay. So with 5G, there'll be an automotive boom, as what we have predicted, because there'll be a lot more innovations that will be happening in automotive. I'm not sure how many of you guys know, but whatever wiring and connectivity you have in your cars today is something that was developed somewhere in the 1970s or the 80s, which is known as the CAN network, which is a low-speed network for various devices or various microcontrollers that are sitting in the car to interact with each other with. With 5G coming in and with a lot of data and everything that is coming in, CAN is slowly being replaced with Ethernet in the cars as well. And with that, there'll be a lot more things that you can do inside the car and the car on its own can do when it is sitting alone. Like you can, like as Tesla has shown, you can summon the car from a parking lot or even tell the car to go and park itself. So those kind of things are in process of happening. And electric cars will be coming in, which will be the future. So not only is there a technical innovation happening inside the car from electronics point of view, but the batteries that will go into the car, the lithium-ion batteries, the lead-acid batteries, and the other technologies in batteries is another thing, which is something that the industry is wanting to crack, because with the increase in the battery capacities, we'll slowly be replacing petrol soon. By 2030 is what I think Mr. Gadkari in India has given a target for having at least 60 to 70% of the cars as electric. So yeah, so electric cars and automobile market is again picking up after a lull for a very long period of time. And there are a lot of things that we'll be doing there in terms of navigations, in terms of what can I say, in terms of navigation, in terms of automated driving, everything will come in with 5G coming in. So this is a trend for automotive industry as such as we have today. So IC is nothing but internal combustion engine. Stop start IC is where the engine stops immediately when you brake and start it again. Hybrid electric vehicles and electric vehicles as such. So for 2015, if you see, 68% of the market today is startup IC engines, and there's a very small market for electric vehicles. But if you go all the way to 2030, the trend completely reverses in that sense that nearly 75% of the market is with different kind of electric vehicles with different batteries, different kinds of technologies, which are not internal combustion engines. So this is a trend that is completely already started, and this is the way it will go forward as far as the automotive industry is concerned. So if you are looking towards something to research, I would say battery is one of the key components that you can work in, because that is something that will grow as we move forward. Finally, AI and IoT. Again, you will have devices talking to each other. Today itself, we have devices like refrigerators and my vacuum cleaners and my Alexa talking to each other and controlling each other through their own language, which is Zigbee or any other thing. There'll be a lot more data going to the cloud where it will be processed and come back to your devices, and your devices can take control of their own and be automated in that sense that you just sit back and it will do everything that is to be done without even you pushing a button. So that is outside, and then obviously there'll be things that are going inside us, which is you'll have pacemakers, stents, which are automated, which will again be based on the data that is going on. Pacemaker will always be connected to the doctor's. So these are all science fiction today, but that is how it will be, that pacemaker is always connected to some kind of a monitor at a hospital somewhere. And as soon as it senses there is something wrong, there'll be a ping going to the doctor immediately that, okay, someone needs critical attention at that point of time. And all this again comes with 5G that is going to come in, because the number of data centers and the number of data transactions that will happen between you and the end node would be increasing at a range of, I guess, 100x as we move forward. So yeah, so this is the IoT trend as we see in 2021. The medical care would go up, your edge computing would go up, smart cities would come into play. Blockchain, which is already there, would be used in many places, not only in banking, but in many other places where security is a major concern. And resilient banking, which is all time on kind of devices, will always be there. So whether it is your trains or everything, they'll be running 24/7 without any human intervention needed. So that's a trend as far as your IoT is concerned. Okay, so that is the trend from a point of view of the industry. Finally, the most interesting part of it, what you should be doing. Focus on studies is something that is a given. We don't really do much there. From an electronics point of view, I would say there are multiple streams that are there as we just saw. We have digital designing, we have analog part coming into it, we have chemistry coming into it with batteries, we have networking, we have clouds. There are a lot of domains in which a guy can work in. So I would say try to find your area of focus, things that interest you. I guess most of these topics are there as far as your engineering is concerned today. You have analog engineering, analog design, you have digital design, you have networking. I believe Tenenbaum was a book that we used to read. I'm not sure whether it is there still. You have antennas, you have RF, anything that interests you, focus on that, see what innovations are happening in those fields, and see what can be done there to improve. Choose what you want to do if you're going into the industry as an engineer today, or probably going for further studies as well. Whether you want to go into designing, further designing, whether you want to do circuit designing, you want to do board designing, you want to do verification, which is testing the designs that are happening, or you want to verify the end silicon before it goes to your customers. I can also add here whether you want to do embedded software onto the chips, whether you want to design that part, the drivers that are running on your chipsets. So choose the stuff that you want to do, and then think what are the innovations or what are the changes that are happening in those specific areas as we move forward. You can go through a lot of scientific journals, IEEE magazines. There are a lot of publications that happen day in and day out. I can quote at least 4 or 5 IEEE papers that I've read in the last 5 days on ADCs and DACs, the analog to digital and digital to analog converters, which talk about different approaches in designing them and how they improve the efficiency, overall efficiency of the DACs and the ADCs that come in. Why I read them is because I am working on that. So, but yes, choose what you are working on. Find papers on that. At least in my time, I didn't know what project to do or what other things to do. I would say the easiest project that an electronic engineer can do is pick up any IEEE paper. They suggest something in terms of the design changes that they are suggesting, or design that they're suggesting for an ADC, DACs, for your arbiters, for anything. Implement that and see whether that is actually matching what is there on the paper or not. That becomes a very good learning experience for you as far as your designing is concerned, and it also gives you an immediate feedback as to whether there is something wrong that you've done, because that is already a proven paper. So if it matches, then yes, what you've done is correct. Otherwise, keep tinkering on it, and that becomes an excellent project that you can do in your 3rd and 4th years if you continue on that path. There are many websites that are there which give you access to all the simulators and all your tools that are used in the industry today. EDA Playground is one of them, which directly gives you access to all the EDA tools that are there, used for RTL designing, for your gate level designings and stuff like that. Play around in that, create your own designs, test them, see where you're going wrong, and what changes affect how in terms of the designs. Get basic knowledge of Unix, Verilog, System Verilog, which are the de facto things that are used in the industry today, at least from electronics point of view. UVM is another thing if you're going into verification. So all these things, Verilog, System Verilog, UVM, are IEEE standards. So if I'm not sure whether Cusat has a student access for IEEE, but if it is there, all these things are freely available to you as of today. So spend time on IEEE explore, find out about these things, take basic knowledge of this, explore that part in terms of how the designs are happening, what are the changes that are happening there, and how you can contribute in terms of changes there. There are things like Raspberry Pi. So there are Raspberry Pi projects available, plethora of them available over the net and over the Raspberry Pi foundations. So it's basically a small computer with different sensors on it, with Wi-Fi, Bluetooth. You can add many sensors to it, whether it is a camera sensor, an impact sensor, a pressure sensor. Create your own systems by looking into those projects, and it gives you a very good idea of how to create an embedded system, how to interact with different drivers, how to integrate them and create a system out of it, which will give you a very good idea as to what an industry user at the end of the day would be facing. All these Raspberry Pis and all these things will be using industry standard chips, industry standard sensors, which are being used in actual phones and everything. You can in fact create your own phone using a Raspberry Pi right now. It's as good a chip as any there in the market right now, and it's freely available for students. It's kits that are coming at very low cost for you guys to try out, for you guys to learn out of it. Finally, you can do many certifications which are available across from various EDA vendors, Cadence, Synopsys. They give online free learning for students. And at the end of that, you'll be getting online certifications which can be used as part of your CVs and resumes once you face the industry that, okay, I've done all this even before coming into the industry, which gives a very good feedback or a learning experience. I would say a very good approach towards the industry that yes, the student who is coming in is already prepared with stuff, and as an industry, we don't have to spend too much time in making them learn all this. Because to be frank, when I started, there was a huge gap in what the college is teaching us and what the industry needs. And I believe that is the same case today, because when I interview freshers today, I still see that gap is there. And that gap can be bridged by following these simple steps of doing what is there. And last but not the least, have fun in your engineering. That's what I did. Make mistakes, learn from them. Yeah, and that's as far as the PPT was concerned. I had planned at least 20 to 25 minutes for all the question and answers you have. So I guess, yeah, we are right on time on that part. So feel free to ask anything you want. I'm free for it.
Thank you, Sharad. Thank you so much. That was a very informative presentation. Guys, you can either unmute yourself or ask in chat box any queries you have, and I'm sure he will be able to, enlighten you more. Anything regarding certifications, internships, anything, please do ask.
Hey, don't worry, I'm not marking you on this, so feel completely free. I am one of you guys. I studied in the same college, sat on the same benches. Don't worry about it.
Any queries, guys, please do ask. You might be having, you might not know what to do, how to do. Ask him. It will help. Please ask. Thank you. Okay, just as a question, which I had, Sharad, I wanted to know. So internships doesn't come easy in electronics field, and I have heard this from a lot of my students too. So I was just, I just wanted to know, like, how can they, unlike ITCS, where you get a lot of LinkedIn notifications, it's not the same for electronics industry. So how do they go about for internships? If they want to do internships, how do they go about it?
Sure. So one thing is that you build your alumni network, because there are guys from the same college who are there already in the industry and are in good positions. And many of these companies do, I would say, offer internships from time to time. It's not only at the end of a session or something, it's throughout the year. You can just go in and do internships. Just be in contact with your alumni, keep in touch with them, ask them that if there are any internship openings, do let you guys know. Yes, it's a fact that the semiconductor industries don't really publish the internships over LinkedIn or those kind of things. But there are internships, so don't worry on that. Contact your alumni, they will help you in this for sure. And that's the easiest way of getting to it.
Okay. Also, could you tell, like, when, you being a manager, whenever you interview people for candidates, so what is the particular certifications you're looking for? Is there anything that you should have which will, any particular certification or any particular knowledge that the students should have and that they would, cut above the rest of the people just because they have that? Is there anything like that?
Yeah. So, like, from a point of view of the academics, everyone, I would treat them as the same. But if you have a certification in or some prior knowledge of Verilog, System Verilog, certifications in that, and probably your projects are the ones that make a big difference from you and the other guy. If your projects are of quality, if you've looked into if you have implemented some IEEE paper, that makes a very big difference if you're going into a big MNC. So if you do that part, yes, it will make you stand out for sure.
Verilog and system Verilog. I'm not sure because I don't know the electronics curriculum. I'm not sure if we have it here. Is there any particular course that can be taken for Verilog system? Is there something? Do you know? Are you aware of it? Or I'm not sure.
Yeah, so there are many sites. Like there is a site called Doulos. I'll probably put it.
Yeah, please put it in chat. Yeah, thank you.
Doulos is one site. Then there is Cadence, which has its own learning websites. So Cadence is an EDA vendor. Again, there is a verification academy. So these are some sites which will help you in getting some free online courses right now. And then EDA Playground is where you can you have the simulators available to compile the code that you write in Verilog and actually run it to see how it is behaving. Because those compilers are very expensive, and I don't think colleges will have that. But they are made available to students on those sites where you can use them, test out your code, and get some proficiency in all this.
Okay, great. Also, one more thing. So we had some IoT workshops last year. I mean, I'm not sure about the electronics part, but we had it in CSIT, whereby we had used a simulator called Tinkercad for making the circuits and things like that. Is that something that the students could do as well? Is that simulation better, or should they actually make the circuits?
Simulation is always better, because at the end of the day, when the industry starts it, they will not be using Tinkercad or all that stuff. They will be actually writing the RTL code and all this, and synthesize that to make a chip. So it will not be through Tinkercad or anything. Because there are the one advantage that you'll get from all these websites, and even from Tinkercad for that matter, is that, see, for a problem there are 10 different solutions. You can attack the problem from 10 different ways and get the solution that you want. But the key is what is the most efficient of them, and that is what will differentiate your product from everyone else. And the only way to figure that out is through simulation and through running that different variations of your design to see which one is giving you a better advantage. And that's where your simulators and everything come into play.
Okay, get it. Guys, questions, please. Whatever I had, I asked, so that if any of you have the same, you never know. Your question, yeah, please go ahead.
Here's a question from Nihal. So could you explain the scope of RF microwave engineers in semiconductor industry?
Oh, there is a big scope for RF engineers in semiconductor industry right now, especially for the wireless part of it and the Wi-Fi part of it. There is, and then on the 5G again, we are talking about micro MIMO antennas that are going to come in instead of the normal antennas that are there for Wi-Fi and the 5G spectrum. So there is a lot of scope, and there is a lot of research that is going on in that. So it depends on which field you want to go to, whether it is development or research. The field is completely open for you in that sense.
Thank you, sir. Parvati has a question. What are the basic components that we should have in our hand as an electronic engineering student?
Okay, so that really depends on the field of work you choose to be in, or you want to be in. If it's something that you want to do in analog circuitry, where it is analog and digital mixed, then definitely analog is a must, and you should be very thorough in your analog design. But if you're going towards digital, then the digital design that you're being taught is something that I would say is a little, there is a gap between what is being taught and what is being used right now. So the basics are all there, but to really use it into making complicated circuits and all is where your Raspberry Pis and all your Tinkle and everything that you're doing in IoT would help. And that is one thing that you should be using in a very big way to get what you learn in the books to be put into practice.
Gauri Priya has a question. For being in the electric vehicle technology, what domain should be focused on?
It's a completely open field for an electric vehicle. So if you're talking about the data that transfers between the electric vehicle and the data centers, it's networking. If you're talking about something inside the vehicle, it's your Ethernet. So that is again networking. If you're talking about how the electric vehicle is connected to the data center, it becomes Wi-Fi, so wireless domain. If you're talking about how to improve the efficiency of the vehicle, it comes into the battery storage, and the charging capacity. So that comes into a mix of electronics and chemistry. So it depends on which part of electric vehicle, again, you want to focus on. But everything that you're learning today, whether it is networking, whether it is Wi-Fi, whether it is your digital circuitry, is being used in electronic vehicles as we speak today.
Thanks, sir.
Also, Sharad, I just had a question. If for masters, if they're planning to go for post graduation, is there any topic that you would recommend because because you are in that industry, and if they want to do further studies, which would be the topic that you would suggest?
One would be AI for sure, because that is one thing. AI computing is growing in a big way right now. So research or masters in AI would be definitely helpful and would be very productive for them in the future for sure. Second, I would say would be in terms of the Wi-Fi part of it, because today we have 5G and pretty soon we've already started the 6G part of it. So the data mining, that comes into the software part of it. But the data management and the data cloud structures, that is one thing that will continuously grow, because our data requirements are growing, so data clouds will grow, and your data centers would grow. So something in terms of data center architectures and all, that is another area of research that we can look at.
Okay. Thank you.
Arjun has a question. The scope of instrumentation engineers in electronic industry.
Instrumentation engineer. So can you just, I am not really sure what that stands for as such. So if you can just elaborate on that part, then I can help you out in that. So what all is covered in instrumentation engineering in Cusat, right?
Arjun, if you could speak up, that would be
You can
really
speak,
helpful.
that's not a problem at all. Okay, so any one of you guys who knows what all is being covered in instrumentation engineering right now? Because I was never interested in that, so I never looked at it in college as well. So
If you could even type in the chat box, that would be really helpful.
okay, I'll park this question for the time being, and I'll definitely get back to you on this question. Now I'll just look into what is there. Basic analog and digital circuits are being covered. Okay, so in that case, if you have a basic ADC, that kind of a knowledge, then definitely you are going towards analog designing, and that is something that, okay, let me put it this way. 90% of the patents that are filed from electronics are in analog domain. So that gives you a kind of idea in terms of how big analog is and how research-oriented analog is and what is the requirements there. So if you're having ADC, that kind of situations, yes, there is a big scope in analog part of it for sure.
Also, Sharad, one thing, some student had asked, I'm not sure whether that student is here or not, but I had asked me quite some time back, with respect to electronics and electrical, when they go into, so there are companies, the companies like Benz and all, who have a big research wing. So how do you? So there are people who would love to get into such places. So how would they go for research? And actually, an electronic student is who asked me regarding this, but I don't know whether that person is here or not. But yeah, so what? How can they work towards that? Like automation in Benz or any other such organizations for research in electrical or electronics. I forget whether.
Right. So, like every company has its own research department, and everyone wants to do that part.
Yes.
And to get into that, first of all, obviously, you have to show that you have an inclination towards research. And how can you show that? By showing in your CV that, yes, I've gone through certain IEEE papers, I've implemented this. So that gives the industry leaders also an idea that, yes, he's a guy who's not completely looking into innovation, he's looking into something in terms of the new things that are coming in. He has published some papers based on his research, or going through the IEEE papers, his implementations, his findings on that. And that you can easily publish into IEEE magazines, which are towards college-based and all that. And if you show that to the industry that, yes, there are some publications in your name, it makes it a cakewalk, I would say, to get into research domain in the industry, rather than just the implementation part of it.
Okay, so I'm not very, I'm not well versed with how you go about a research paper. I've never done it myself. So if they are like these students right here, they might be S2, S4, S6. What do they do in order to, write a paper or publish it in IEEE? Is there a criteria for IEEE or something?
No, there's no real criteria on that. So I would say the easiest way to publish a paper in IEEE right now for any one of your students would be take any existing IEEE paper on any design, take 2 of them, make that as a project, implement both of them, take their comparisons, and make that as a comparative study and publish that as a paper in IEEE magazine. It's the easiest way of getting paper published right now. Okay. And once you do all these kind of stuff, A, you're getting knowledge of different implementations. B, you have publications in your belt, and that helps you in getting recognition across.
So do you, just as out of curiosity, do you need any mentor for this? Like you need a faculty to see your paper or something, or is it something you can do independently?
You can do independently, but there is a certain format. So if you are going through multiple papers, you will clearly understand the format in which the paper is supposed to be. And there is supposed to be an abstract, and there's a certain format, and there is a conclusion, citations, and everything. So there is a format to which a paper is all about. So if the faculty has had some papers under his belt also, it adds that much more weightage to your paper. So if something like that is existing, then yes, it will give you a weightage. But otherwise also, at least in the IEEE college magazines, the papers can be easily published. And that also gives a lot of weightage, yes.
Okay. Oh, so that's something you guys can look into, guys. I really think all your faculty would help you out. You can look into permanent faculties who have, done research or something, and then try and get them to mentor you. There's another question.
Which are the core companies hiring freshers in electronics engineering without GATE exam?
Oh, all of them: Cisco, Qualcomm, Texas Instruments, NXP. These are, I'm talking about the MNCs, but then there are many like Veladile System, which is working on the LiDARs, just started, Nuvia, NVIDIA. All of them are hiring freshers. There's a boom going on right now in the industry, and everyone is looking for more and more headcounts to implement their chipsets. So all of them are hiring right now.
So I had a question, basically while right now, we try to post job posts or internships, anything which we come across via LinkedIn but for jobs in electrical and electronics, it's a bit difficult to find them on LinkedIn. So other than getting those job posts from our alumni, is there any other way we could, get those job posts like internships or anything? Yeah.
Other than that, I believe there used to be a website. I've stopped post. Let me check on the name of the website and get back to you. But there are a couple of websites on which these companies do post for internships and everything. So I'll just get back to you on the names of that for sure. And that will give you an idea as to where the internships are opening up and when they're opening up and what are the exact requirements they need from an engineer at that point of time.
Sure. Yeah, thank you, sir. That would be really helpful.
That would be really nice, Sharad. Yeah, seriously, because that is one thing that everybody was just saying that, unlike CSIT, they're just not getting the break. They're just not getting the opportunity.
Yeah, internship in electronics is a pain point. I remember how kitne papad belne padte the to get one internship across the industry.
Yes. And it's the same for others too, whether it's mechanical, civil. So but because of lockdown, I think electronics, electrical have more opportunities now.
Oh yes, for sure.
Yeah, which students don't realize, I think. So it's great that you could shed light on that part of it. So,
I mean, I would suggest that if you are in electronics, don't move out. I can give you a snapshot of today that my company today has bookings in terms of the money paid by the customer for the chipsets, which they'll be getting 2 years down the line. So that's how long the booking is. That's how long they are waiting for our chips to go out. And that's how difficult it is to get a chipset right now in the industry. And that's how in demand the industry is. The automobile industry totally is in a slowdown because they are not able to get the chipsets from manufacturers like us. So it's a big boom. Don't move out of electronics. It will always be there, and it will only grow.
Actually, on that note, could you just share how your journey from after BTech and like your how you started off and to where you are right now? If you could just give a brief glimpse to the students as well, that would inspire them.
Sure. So after BTech, we were in a slump at that point of time. There was a big industry slowdown. So we had a gap from our passing out to our joining. I was placed in campus in Wipro. That was the first company that came and I was placed there. But there was a gap from passing out to joining. So that is the time I utilized again for going through papers and everything in IEEE and try to do something on Raspberry Pi and fiddle with that. That was the learning part of it. And once you get into the industry from there on, I was lucky enough to continue in electronics from there on because most of my batchmates have moved to CS and everything. And I had a choice and I continued with this. From there, we moved into telecom, which was Freescale and Motorola at that point of time. Worked a lot there. And from there, moved into Qualcomm, where I worked on the Snapdragons that are going into your chipsets. So many of them are designed in India, tested in India. And that's what I led a few teams in working on those stuff. And then finally moved into Broadcom, where we moved into testing, started with set-top boxes. So almost all your Tata Sky, Dish TV boxes has a Broadcom inside it, which is probably designed out of India and has been tested here in India. And to today, where we are working on different networking chipsets which go into your data centers. So all Facebooks, Amazons, Netflix that you are streaming right now is going through a chip from Broadcom, which is sitting inside the data center. And that has some contribution from our team in India as well. So that's how the growth is, and that's how where the end products that we work on land up in. So that gives a lot of satisfaction in that sense that yes, we have worked on something that we are using right now.
Wow, fantastic. That was really fantastic. I mean, I'm sure students, you would really, hopefully be inspired the way, he has gone from different companies, learned a lot on the way. So that's something that is a takeaway for you people as well.
And one more caveat on a lighter note, an electronics engineer in electronics will be paid in terms of salary at least twice or thrice what a computer engineer at the same experience level would be getting. That I can assure you. So pay-wise, there will be no competition at all.
Okay. So hear that. So now all of you who are planning to go for CSIT placements, कि कुछ और नहीं आ रहा है campus में, start working towards it so that you can go out there on off campus and go get your jobs in electronics and not get into IT and like, hi, IT mein kyun aa gaya, electronics acha tha type thing, because I get a lot of students who do that, who go into IT and then 1 year, 2 year down, and I tell them don't go, and then 2 years
right,
down
because
they come back.
The thing is, once you move into that field, there is no coming back from there.
Yes, true. So, very true.
Think twice before taking a step towards electronics. If you're not getting anything right now, probably study further, go to MTech, do a PhD. But try to stick to your domain, the one that you've chosen for the next 4 years of your life, which is studying electronics. So try to stick to that, and that should help you in the long run for sure.
Wow, that really helps, Sharad, because what you said is right. These students who have gone to IT, there is no coming back because the next job will always be based on your previous job, and then
right, exactly.
What happened to electronics? You left it in college, so you can't get an electronics job based on IT experience. So
for sure.
Yeah, so it was great. Any questions, guys? Any more questions? We still have a few more minutes. Anything you want to ask, Sharad? Please feel free. Please don't be shy. You've got this great speaker right here. To interact, which is something you won't normally get. So please utilize it. please ask your doubts away.
Anything, whether it is college or your work, anything that you want to ask, feel free to ask. No issues there.
Seems like a very, very silent batch, but I'm sure they are hearing in. I'm sure about that. I'm sure they have learned a lot, and I hope you people go out there, build your circuits, put on your papers in IEEE, and now you know what you need to do to boost up your resume. So hopefully that will help you at some point, any point, every point of your life. So yeah, is that it? Anybody? Any questions in chat box, or you can unmute yourself? No?
Okay, so if that's it, then yeah, feel free to reach to me, guys, if there's anything that you want to ask.
Somebody's asked for whether we can get your contact information.
Okay. That's my email ID. Feel free to contact me anytime you want. And
Thank you, Sharad. Thank you so much. It was really a very enlightening session, because I think this is a field which not many people, like you said, in your batch itself, there are not many people who still stick on, but they don't realize what an awesome field it is, getting much more money than IT. So that should be.
That's one thing that I tease my batchmates for sure, that whoever has moved to IT, that yes, compare the salaries now.
Yes. And see, that should tell them, that should quieten all your other doubts. Like, don't go immediately कि campus में यही आ रहा है तो इसी में घुस जाओ. Don't do that. Okay, stick with you are in this branch for a reason. Stick with it, and you can already see how Sharad.
Yeah, definitely, it's a field that will always give you a lot if you give it a lot. Stick to it, give everything, and you'll get everything out of it. That's as simple as it is.
That's a wonderful thought, Sharad. That's really a wonderful thought. Guys, please do abide by it. I hope you do get inspired to stay with your own field and then become great electrical engineers, and one day thank Sharad sir for this beautiful speech that he gave. So it's really good, Sharad. You really opened a lot of eyes, I'm sure, especially with the salary bracket, for sure. Because that's what guys nowadays want to know first.
Yeah, so that's what finally what we are aiming towards. So yeah, that was one thing that I thought it would be good for them to know.
Yes,
in that sense.
Yes. For sure. Because they once you get into the industry, changing is very hard. So stick with it, through it, and I'm sure it'll pay. Your efforts would be paid for sure. So yeah. So thank you so much, Sharad, for your time. Thank you so much for taking time for this. Thank you so much.
Thanks.
Thank you. Thanks a lot.
Thanks, guys. Thanks. Bye.
Thank you, guys. And next week, again, we'll be having a cloud expert who will be talking to you about a day in his life about cloud. So yes, please do join us next Saturday then. Thank you and have a beautiful weekend. Take care.